Hi, welcome to the Applied Data Science course for beginners. I'm Gurami, and in this tutorial we will discuss theoretical part of one of the popular machine learning algorithms, logistic regression. In the end of the tutorial, you will learn what's a classification problem, what's a logistic regression and how it works, as well as its hypothesis function and loss functions. I'm really excited, and let's jump and get started. As a reminder, machine learning is divided into 4 parts. In this tutorial, we will focus on supervised learning classification tasks. What is a classification problem? Imagine we have a patient which has the following records: a glucose concentration 197, blood pressure 70, skin thickness 45, BMI 30.5, age 45. And our goal is to diagnose if a person has a diabetes or not, based on this information. The question is that, how are we going to solve this problem? We analyze other patients for which we have the information and also the knowledge whether they have a diabetes or not. This dataset is called a label dataset. Here in the bottom right, you can see a sample of the dataset. We have 5 patients, and each of the patient has the information related to glucose, blood pressure, skin thickness, BMI, age, and also we have a label whether they have a diabetes or not. This label is called a ground truth. From machine learning perspective, we call glucose concentration, blood pressure, skin thickness, BMI, and age input features, which are denoted as x1 up to x5. Each feature has its own weight: W1, W2, W3, W4, W5. We have trained machine learning model, and the output of this model is whether a person has a diabetes or not. Some kind of binary classification. Question is that, how we find some hidden function which somehow converts all combination of inputs and weights to output. Even though we have features, we don't know its weights. We don't know the exact value of W1, W2, W3, W4, and W5. Here is where machine learning comes in. Almost all machine learning algorithms have the same workflow. First, we initialize weights randomly. Then, we calculate hypothesis function output. After that, we calculate total loss. And we update weights using SGD or other optimizer. This process is iterative, and after that we calculate hypothesis function again using updated weights. We calculate total loss again with updated weights, and we update the weights again. What is our goal? Our goal is to minimize total loss. Logistic regression, as we mentioned, is one of the machine learning algorithms which has its own hypothesis function, which is represented as this function, in which weights are W1 up to Wn, bias is W0, feature values are from x1 to xn. The thing is that the output of logistic regression hypothesis function changes from 0 to 1. Also, it has its own loss function, which in other words is total difference between prediction value and ground truth. Loss function is the sum of all the cost functions divided by m, which is total number of examples. Each of the cost function of individuals is calculated based on these functions. If ground truth value is 1, then the cost function is minus logarithmic hypothesis function. If ground truth is 0, the value will be minus logarithmic 1 minus hypothesis function. For example, when we have these input features, these features are fed into logistic regression hypothesis function, which is in this case the function below, and the output will be from 0 to 1 as we discussed. Let's say it's 0.64. If we have a threshold to 0.5, this means that this person has diabetes. Okay, let's discuss full example of machine learning problem. Imagine we have dataset of 20 patients and we need to build a machine learning model using logistic regression. First step that we will do is to initialize weights randomly. In this case, because we have 5 features such as glucose, blood pressure, skin thickness, BMI, age, we will have 5 associated weights for each individual feature, plus bias. For example, here is random weights associated to each feature. Second step is to calculate hypothesis function. We have hypothesis function for logistic regression, and we can calculate the score for each individual patient. For example, for patient 1, if we plug in our known values, we will get 0.66. We can do the same for patient 2 up to patient 20. The third step that we will do is to calculate total loss. What is total loss? Total loss is summation of individual cost functions divided by total number of patients, in this case 20. For patient 1, cost value equals to minus logarithmic 0.66, which is 0.18. For patient 2, the cost function will be minus logarithmic 1 minus some value. It is because for each individual patient, we use different cost function, which is depend on the ground truth label. In this case, if ground truth label is 1, we use minus logarithmic hx function. If the ground truth is 0, we use minus logarithmic 1 minus hx. The last step is to update weights using SGD or other optimizer. In this case, new weights equals to current weight minus alpha multiplied by gradient. And I will discuss SGD in more details in the next following videos. We will do step 2, step 3, step 4 iteratively again and again until loss function achieves local minimum, or in other words, gradient will be almost 0. Just an extra information, why do we need bias in machine learning algorithms? We use bias term in order to shift the position of the curve left or right. It is the end of the tutorial. To sum up, we have discussed what is a classification problem and its algorithm, logistic regression, as well as its hypothesis function and loss functions. In the next tutorial, we will do a practice example of logistic regression using scikit-learn library by building a real-world project about a person's diabetes diagnosis. I hope you liked it. Make sure you subscribe in order not to miss it. See you in the next video.